Alrighty, so today we're going to combine like terms but using radicals. So quick refresher review. Like let's say I had to add the monomial 3x plus 4x together. Well, they have the same base, xx, with the same exponent 1, 1, so we just add the coefficients, right? 3 plus 4, 7x, and that's your final answer. Now take a look at the next example, 5y minus 3x plus 4y. It might help to circle, but of the three terms here, 5y, 4y are the like terms. So 5 plus 4 is 9, 9y. The exponents do not change, but then minus 3x tails. So what happens when we work with radicals, sometimes we have more than one radical, and we have to try to combine like terms. So let's take a look at this first example. Simplify the radical if it's necessary, then combine the like radicals. In part A here, 2 square roots of 3 plus 5 square roots of 3, they are like terms. They both have the same number 3 inside the radical sign. So what we're going to do then is going to take 2 and the 5, those are the coefficients. We're going to add them, so I get 7 square roots of 3, and then we're done. Here's another example. Look at the square root of 2, the square root of 2. These are like terms. So now we're just going to take 4 minus 9, that's a negative 5, radical 2. So these two first examples, we have like terms. Just combine these like radicals together and we're done. We might need a calculator if we're a little rusty on our positive and negative numbers, right? And that's okay. But what might be helpful is having a colored pen or a colored pencil, and let's find some more like terms. Like for instance, letter C, 3 square roots of 5 and square root of 5. I might suggest putting an invisible 1 there in front. Those are like terms. So 3 plus 1 means we have here 4 square roots of 5. Now this square root of 2 and that square root of 2, those are like terms. So what would 6 minus 3 be? 3. 3 square roots of 2. Now, how do we separate these two terms? Well, since 3 was positive, guess what I'm going to put in front here? You got it, a plus sign. So how do the problems get more difficult? Well, sometimes we'll throw in some review work from last week. Do you remember last week how we were simplifying just simple square roots? Like, don't even pay attention to the example there of the 4 square roots of 2. You might remember last week we had problems just simplifying something as simple as 9 square roots of 18. So mentally block that out. What do? We'll leave the 9 alone and try to think of the factor pairs of 18 where one of them is a perfect square. 3 and 6, no, 3 is not a perfect square, nor 6, but I know 9 times 2. So I'll break up the 18 using the square root of 9 times square root of 2. Now the 9 stays out in front. The square root of 9 is 3, so we're going to have here 9 times 3 square roots of 2. And guess what we get here? 27 square roots of 2. Now, that's all we would do last week. But we're going to be adding and subtracting radicals this week. So what happens here now, we have to bring down that 4 square roots of 2, and we're going to add 27 square roots of 2. Square roots of 2 are both the same. Just have to figure out what 4 plus 27 is. You got it. 31 square roots of 2. Now what's nice about this problem is, hey, I know that these two are eventually going to join together. Could I perhaps use this square root of 2 to help jumpstart my thinking to break down the 18? And guess what the answer to that is? Yes. It's a great little strategy. It helps you to reinforce what we did last week if you're having a hard time finding those perfect squares. So like for instance, letter E. I know at some point I'm going to try to combine these two, but they both have to have 10 inside the square. Oh, that's right. I can change the 40. So it's the square root of 4 times the square root of 10. Leave the minus square root of 10 alone. It's just waiting. Figure out what we're going to do with it next. 7, the square root of 4 is 2. Square root of 10 minus the square root of 10. So remember your orders of operations, you got to multiply. So you really have 14 square roots of 10. And we're going to take one of them away. So if you want to write an invisible 1 here, by all means, please do. But we're going to eventually have only 13 square roots of 10. And that's our final answer. Now the worst case scenario, most of the times your problems will be reasonable where you're adding or subtracting. So hopefully you can use one of the numbers inside the radical sign to help jumpstart your simplification of the other. But letter F is the worst kind. It's like, oh my gosh, where do I begin? Well, let's start with a 27. Think of the factor pairs, the two numbers that multiply together, they give you 27 where one's a perfect square. Okay, 9 and 3. So the square root of 9 is 3 and the square root of 3 drops down. Now I still see in this problem, I'm hoping to join like terms, but we have a situation here. If we're going to join like terms here, I would think that there'd be a 3 inside the square root of 20. Is there? No hopes of that, no. So like I said, it's the worst case scenario. You have two different factors, two different radicals to worry about. We're going to break down the 20 using square root of 4 times square root of 5. So I'll have your 2 times square root of 5. And oh my, we end up getting as our final answer this. And this is the worst case scenario. We cannot add these two radicals together because the 5 inside here of the 3, these two are not like terms. So you would stop and leave your answers just like that. Remember like we did up here before? Last time I knew x and y's were not the same, so you have a binomial there. Guess what you have here? You have a binomial, no problem. Worst case scenario, so watch out for that. Let's look at one more example here. We just did square root of 27. So what you'll find, I'm not sure if you noticed the pattern yet, there's only so many perfect squares out there, so many factor pairs, so some of these numbers get very repetitive. So I break down 27, I'm going to use 9 and 3. Now the square root of 9 is 3, so 2 times 3 times the square root of 3 gives me 6 square roots of 3. That's my simplified. So we're going to simplify the radical first. 75, remember we did it last week, 3/4 makes 75 cents. So I'm going to use 25 and 3. And the square root of 25 is 5, square root of 3. And guess what? These square roots of 3, oh my gosh, they're like terms. So we'll get here 6 plus 5, which is 11 square roots of 3. So you might need to watch a video another couple more minutes, a few more times, just to get the gist of it. But what we have in common from last week is, last week you only were given one radical and you had to simplify it down. And the key was the perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, right? It keeps going. Numbers get big too. But look at those perfect squares to help you jot down some of your factor pairs so you can simplify these radicals. Now remember, the easiest case scenario right off the bat, if the radicals already are like terms, you just work with the coefficients, either add them or subtract them. The worst case scenario, you have to use one to hopefully help you jumpstart your factor pairs, like we did with letter D, as well as letter E. Worst case scenario, it happens. I'll try to stay away from them, but you know what? I may not be your last math teacher in your lifetime, right? So when you go to college, don't be surprised if you see things like this. Hang tight. Hopefully you'll remember these little notes that we've talked about and these video clips, but letter G, believe it or not, is something I've seen on old Regents exams. So it's in there. It's in the course. Okay, good luck. Let me know if you have any questions.